This video, we're going to solve application problems using the law of cosines. This first problem, we have a student pilot flying from Champaign to Peoria and got the heading wrong by 8 degrees. The original distance was 83 miles, and he went quarter of an hour at 80 miles an hour. He went 20 miles before the instructor realized that they were off course. They now need to course correct, and we want to find this distance here that they need to correct, and we want to find this angle here that they need to turn to get back on course. So x squared is equal to 83 squared plus 20 squared minus 2 times 83 times 20 cosine of 8 degrees. 83 squared plus 20 squared is 7289 minus 2 times 83 times 20 is 3320 cosine of 8. $72.89 minus 33.20 cosine of 8. X squared is that. So x is equal to the square root of this, which is approximately 63.26 miles. Now that I have that distance, I can use the law of sines to find angle I. Sine of angle I over 83 miles is equal to sine of 8 degrees over 63.26 miles. So sine of angle I is equal to 83 sine of 8 over 63.26, meaning that I is the arc sine of that. Divided by 63.26, and that's not actually angle I, because angle I is going to be obtuse. This is actually the angle that I want, that is 180 minus angle I, but that's okay. This is what I'm actually looking for, that my turning angle is going to be 10.5 degrees. So I need to turn back 10.5 degrees. This angle here was much bigger than I drew. I did not draw this to scale. This angle is actually 169.5. So we have a huge angle I here. This was 8 degrees. This was 169.5. He was off course here by 10.5 degrees that he had to turn back. And this was 83, and this was 20, and this was 63.26. Okay. It's a better look at what the situation is going to be like. Let's clear the canvas here. 2 points A and B are on opposite sides of a building. By opposite, we mean that they're on the diagonal. So let's make this A and B. We're going to have to pick a transit point out here, C, where we can see both points A and B. Like so. We want to, even though we can't probably walk through the center of the building like that, we want to know this distance between A and B. If we know that the distance from the transit point C to point A is 45 feet, and from the transit point C to point B is 73 feet, and that this angle is 53 degrees. So we should be able to say that x squared is equal to 45 squared plus 73 squared minus 2 times 45 times 73 cosine of 53 degrees. So x is going to be the square root of that. 45 squared plus 73 squared minus 2 times 45 times 73 cosine of 53 degrees, and x is going to be about 58.3 feet. This next one is about baseball. We have a line that goes from home plate to dead center field. We're going to have another line here that's going to go to first base, and we want to know this distance from first base to dead center. If we know that this line, that there's another, these sides are 90 here, this line is going to bisect this 90-degree angle here, which means that this angle over here is 45 degrees. That's why I needed to know that it was a square. And this distance to center field is 405 feet from home plate. You see the numbers out on the wall. This, I said already, was 90 feet to go from home to first. So we have side, angle, side. We're going to use the law of cosines here to say that x squared is equal to 405 squared plus 90 squared minus 2 times 405 times 90 times the cosine of 45 degrees. So x is going to be the square root of all that. 405 squared plus 90 squared minus 2 times 405 times 90 times the cosine of 45 degrees. And we get x to be about 347.2 feet. Now we're trying to get from island A to island B, and they are originally going to be 250 miles away from each other here, if I went on the correct heading, but the captain went way in the wrong direction here. So he heads this way, say, and he gets 150 miles away. Sorry, this is 150 originally. And he goes 250 miles and is like, I must be going the wrong way because I was only supposed to go 150 miles to get to my destination. I'm already 100 miles more than I was supposed to go. So he realizes that he's off course. They take some other measurement. They find island B over there, and they realize that they're now 160 miles away from island B, further away than they were when they were at point A over here. So now he needs to turn, and he needs to make a big turn, not a little turn. So our angle here is going to be really big. It should be an obtuse angle. Just to let you know, he's going to have to turn more than 90 degrees. So make sure you get the right angle here, because you could be getting the little angle here and you need the big angle that he needs for the course correction. All right. So let's solve for this angle up here, which we need 180 minus that angle. But let's get angle C. So C squared is equal to A squared plus B squared minus 2AB cosine of C. So 150 squared minus 160 squared minus 250 squared, big negative number over here, 65, 600, negative 2 times 160 times 250. It's another big negative number, 800 cosine of C. 600 divided by 80,000. 0.82. Our cosine of 0.82. And we get this angle, but we need 180 minus that angle. So we need the 145.08 for the angle that we need to turn. Right, and last one for this video. Have a ladder leaning against a wall that's not perpendicular to the ground. The wall is leaning. The wall makes a 96-degree angle with the ground. The ladder is 23 feet away from the base of the wall, and it reaches a point 52 feet up the wall here, and we want to know the length of the ladder to the nearest foot. So we have a side angle side situation. We have x squared equals first side squared plus second side squared minus 2 times the product of those two sides times the cosine of the angle between those two sides. And we get the x is going to be the square root of all that. (23) squared plus 52 squared minus 2 times 23 times 52 cosine of 96 degrees. And to the nearest foot, the ladder is 59 feet long. That's it for this section. Come back next time and we'll start talking about some things in our last unit with polar coordinates and vectors. We'll see you for that.